In this lecture, let's discuss about Cortex M processor core registers. Okay. So again, I'm going to refer to the generic user guide of the Cortex M4 devices. Okay. And the discussion will be similar if you have Cortex M3, M0 processor based microcontroller. Okay. So the discussion will always hold good. Now in this document, I just open this section core registers, and here you can see that these are the processor core registers. Okay, and these core registers are actually residing under this Cortex M4 core, or Cortex M processor core. Okay, so here you can see that the registers from R0 to R12 are general purpose registers. Okay, so that means, so I'll just write that. Okay, R0 to R12 registers are for general purpose. Okay, so that means these registers are not to R12. You can use it for general purpose, like for data operation, data manipulation, to store data, to store addresses, etc. And all the registers, all the core registers are 32-bit wide. Great. So now let's move forward. The register R13 is called as stack pointer. Okay, so I'll just write that. The register R13 is called as SP, that stands for stack pointer. So that means this register is actually used to track the stack memory. Okay, so I will talk about stack memory and the stack pointers in detail, in the subsequent lectures. Okay, but for the time being, just know that R13 is a stack pointer which is used to track the stack memory. And beside this R13 register, two more registers are mentioned. That is PSP, which stands for processor stack pointer, and MSP, which stands for main stack pointer. And these registers are called as banked version of stack pointer. Okay, so more on this I will cover later. So all these three are actually stack pointers. Okay, but one among these will be active depending upon the mode of the processor, which I will talk later. Okay, so don't worry about that. So now let's move forward. Now the register R14 is called as the LR. LR stands for link register. Okay, so now what we'll do is we will go to the description of the LR and we'll read about that. Okay, so I'll just go to this link here. Okay, and it takes me to the description of the link register. Okay, just read this sentence. The link register is register R14. It stores the written information for subroutines, function calls, and exceptions. Okay, on reset, the processor sets the LR value to this value. Okay, so now let's not give much stress upon this sentence, but this sentence is very, very important, that the register R14 stores the written information for subroutine, or function call or exception. Okay, so now to understand this, what we'll do is we'll execute a small program on our board and we will try to understand the behavior of the link register. Great. So now let me go back to my Keel project, and this is a Blinky application we have executed previously. Okay, so here what I do is I just put a breakpoint here, and I'll just compile this and I'll just download this to my hardware. Okay, all right, so now let me download this code, and what I do now is I'll just go into my debug mode. Okay, all right, so now what I do is I just open this registers window here and just observe the LR register. Okay, now also open this disassembly here. Okay, so let me just adjust this windows. Okay, so now take a look into the assembly code generated for this code block. Okay, so first line of our main function is, okay, call the function LED initialize, right? So what is the instruction generated for this line? That is this one, right? Branch, okay, BL means branch to LED initialize. So that means the LED initialize is actually implemented here at this address. Okay, so that means this instruction will branch to this address now. Okay, and after this instruction, so this is the next instruction, right? So this is the next instruction. So once the processor goes into this address, okay, so then how does it know to come back to the next instruction which follows right after this line? Okay, so someone has to hold the return address, right? This is a return address, right? So this is the address the program counter about to visit, and after this function, okay, it has to return to this address. So what happens? So before branching to this address, okay, so what the processor does is it will store this return address into the register called LR. So that's the link register. Okay, so now let's see how this works. Okay, now let's see that practically. So our expectation is once I enter into this function, the LR has to be loaded, okay, with the return address, which is this one, 5DA. Okay, so let's see. So I'll just hit single step now. Okay, and yes, we came to the function LED initialize. Okay, and just observe the value of R14. It is holding 0 cross 08 000 5DB instead of 5DA. The last bit of this address is incremented by 1. So that means when the control comes to the LED initialize function, okay, at this address, okay, you can see that PC is actually holding the address of the first instruction of this function, which is this one, and LR is holding the return address. Okay, so that return address will be used when the processor want to exit from this function. So where it exits from this function? Here at return 0, isn't it? So here, if I come over here, okay, I'll just run, and now the processor is about to leave or exit this function, right? In that case, okay, the LR value is actually copied into the program counter. Okay, and here you can also see that, so return is implemented by these instructions. Okay, move as, add, and pop. Okay, actually at this point, pop PC, the return actually takes place. So I'll just remove this breakpoint and I'll just come over here. Okay, here you can see we are still at returning from this function. Okay, and this instruction, what it does is it will pop the value of LR, okay, so which is actually pushed to stack. Okay, that value will be popped into PC. Okay, so now if I just remove this breakpoint and if I just single step, then okay, that 5DA, okay, will be copied to this PC. Okay, so just observe that. Okay, I'll just hit single step now, and here it is, the 5DA came back. Okay, so that is the address of the next instruction after, okay, this line, isn't it? Okay, so that means the processor successfully finished this function and it came back to the next instruction after this line. Okay, so the next instruction is actually this one. Okay, so that's the purpose of link register. It is used to hold the return address of the program. Okay, and the link register also used to hold the return information, okay, during exceptions. Okay, so that I will discuss later when I discuss about the exception handling. Okay,